Good afternoon, everyone. My name is Rodrigo Vale, and I'm going to talk you about my project, Topology for the Spatial Distribution Networks. This project is based on my experience in a gas company, and let's go. My first objective, or my main objectives, is explain the advantages that we have to build a topology for distribution networks. And all my presentation is based on water context, but you can use for gas, electricity, or telecommunications, which context with your specific elements. After explain how can we build a topology, first steps, elements that are used, and adjustments. And in the end, I'm going to show you some practical results based in a QGIS plugin that I developed. Here we have some gas companies, some electricity companies, telecommunication companies, and water companies. And here we can see that have many opportunities to use these spatial distribution networks. Benefits. The first benefit is to create a smart network. I have a picture here. In this side, we have elements not connected without any hole or restriction. And in the right panel, we have a topology defined and respected. We can see, in this case, I am representing the network with supply with blue, and in black, a network without supply. This other example is very interesting. It's a real situation. It's an article published in the LinkedIn that an operator try to understand what's happening with your network. This is a real situation. This is the code for this article. The operator, he joined many pieces of a map and is trying to understand what's happening in your network. And with this example, we can see how happened this dependency for operator. This is a real situation in Baiatuba. They call it this solution a balloon. Other benefits, very important, is you can make system integrations, extract informations. Talking a little or give some examples of integrations, we can have ERP, EAM solutions integrated with GIS. You can get fixtures based on CAD solutions. You can export your fixtures for a simulation system, and you can interact with Cada systems and many other things. Network analysis. We can use this topology to extract acknowledgement, and we can see critical regions, how are my supplied for critical clients, for example, hospitals. In this context, is a little bit small, but we have 2 hospitals, and we can see how my network is attending these 2 customers. And the other very big important analysis is the region criticals. Let me change. Here you can see this yellow segment is a segment selected, and this is a fixture action that I will show you after. But we can see that closing, if I want to close only this segment, I need to close 8 or 9 valves, and all this region will be affected. after we see some another examples. And how I told you, after we define a topology, we can make actions over this network. Segments isolation is the example that I showed you. And you can make manipulation of valves, see which customers will be affected with this operation, and you can build new features. How to build a topology? This is a very simple example, but first you need to define the elements. In my context, I define segments, valves, customers, and reservoirs. And after we define the elements, we must define the properties that are the attributes. We can have diameter, status, etc., and define properties and behaviors. And the connections between these elements, limits, restrictions, anyway. In this picture, I have some example. After I detailed more, we have a valve represented by this circle. A square is a reservoir, clients in triangles, and the segments. Here in more details, like I said, we have segments representing our network like a linear element. All others are point elements, a valve that make the control flow. The customers is the end, the node of our network, and the reservoir is the start. After defining the elements, we must define the syntax, that are the properties that we have in each one element. I make a very simple creation anyway, and a very important property or field is status for valves, and this must be open or closed. After define elements, define the syntax, we must define the semantic. The semantic is how these elements will interact with each other. In the case of segments, we can have 2, 3, or 4 segments connected. Valves must be connected always between 2 segments. Customers connected only in 1 segment. And reservoirs, we can have 1 or 2 connections. After define the elements, after define the syntax and the semantics, we must make the adjustments. First, in the syntax, I selected two elements for some examples. We must correct not null values, validate the types, and make a conference if all values is correct. In the case of status, attribute status, the values must be open or closed. And we must make adjustments on semantic. This is the more strong or the biggest effort, because usually we have thousands of features, and this is some cases of situations that you must correct. For example, disconnected segments. This is simple. We just need to put in the correct position. In this other example, we have 2 segments, but I need to divide this first to put could connect correctly this other one. Same thing with valves. In this other context, I have a valve that must be connected, but I have only 1 segment. I must divide and put the valve in the correct place. This other one is a very simple example. This can be used for a reservoir or for a client, just adjusting the position. The project. My project starts with the shapefiles of the Sulgas, that is gas company from Rio Grande do Sul. And I got the segments and start my code anyway, using Python, first only with GDAL, and using the library for graphs of Python, but was very, very difficult to understand what's happening. Then I decided to use the QGIS like an interface to understand what was happening. First, just with only a script, and after I developed a simple plugin. At the moment, after I got the context of the city Valinhos from São Paulo, and I got segments, valves, and reservoirs, and I got other 2 companies of gas, only with segments. And now we are here in the Congress. Okay. This is the first feature I developed. What is the network analysis? This feature have how objective show us what is wrong according with our topology. In the case of segments, what could be wrong is only a single segment or disconnected segments. Single segment is a segment that have no connection to anyone. This guy, for example. Change. In valves, we can valves only with only one connection, more than 2 connections, or disconnected. Remembering, the valves must be connected to two segments, only 2 segments. Customers, more than 1 connection, or disconnected. Reservoir, only disconnected. I have a video explaining, showing it working. This context is the city from Valinhos. Some segments I create to show the problem. This is a single segment. This is a not connected valve, a not connected reservoir, and a not connected customer. Here we have a valve with more than 2 connections, 3 connections in this case. Here the same thing, 3 connections. And now I have many valves connected to only 1 segment. And I think more client is connected. All these kind of things, all these problems must be corrected for we have the correct manipulation of our network. This is network analysis. After we have network status. Based on reservoirs and valves open and closed, I have a code that define if the network is supplied or unsupplied. I use blue for supplied and black for unsupplied. Green for open valves and closed red valves. The network status is a first step for our manipulation, open and closed valves. In my plugin, if the valve is open, I closed. If it's closed, I open. I just do these 2 movements. And I include, in this case, a selected valve that, sorry. And we have the selected valves. In this context, this picture, we have 3 valves selected. And here we have another example. In this context, I want to isolate this area. I close this valve, and after I close this other one. This context is very simple to understand what's happening. I have another context. For example, if I want to isolate this region, I first try with this, not enough. After this other one, not enough yet. And after I try with this valve. And then, yes, finally I could isolate these segments. And I can see that I have a supply from here and from here. This is the open and close valves. And the last action or feature is the network isolation. This is a very important action for the people from operation, because the network isolation is the context that we have a rupture in our pipes. I define selected segment in yellow, isolated in red, and affected in purple. What's the difference between isolated and affected? Isolated regions, we cannot separate from the selected segment. Affected regions or segments, we can, closing specific valves, we can, in this case this and this other one, we can isolate this area. Valves related, we have this big circle representing the valves that we must close to cut the supply. The small circle, let me change my magic presenter. Here we can see this small close this region, and this other one, this small region. And we have yet valves that have no difference. This is valves that if you open or if you close, you have no difference in your context. And in the end, you have the clients, customers that have, or affected customers with this manipulation. I have another example. This is the same segment for the picture. I select the segment and I make the isolation. And here we can see we need close 5 valves. These 2 valves have no difference. This valve isolate or separate this region and this other region, that valve. I select another segment and make the isolation. And in this other context, I have 4 valves to close, and I have 3 affected clients. And one last simulation, isolation. I have only these 2 valves to close, and I have nothing affected. This is the network isolation, and thank you for attention.